This list has been partially sorted using insertion sort. The question is, what number to put inside the empty box so that next time insert runs, it will perform the least number of steps necessary? The answer is any number that will require no swaps with anything from the sorted part of the list, and that is anything that is greater than or equal to 4. In our case, let's pick 5. 5 will get checked against 4, it'll turn out that it's in its proper place, and it'll stay there. Now let's look at the code for insert, with docstrings and comments omitted. The while loop in the middle requires that L at I minus 1 is greater than value. And value is, in our case, 5. And because 5 is greater than 4, the second half of that while loop condition will fail, and the loop will never run. So how many assignment statements are we executing here? If the while loop doesn't run at all, the only two statements we execute are value equals L at I, and L at I equals value. That is 2 statements. Now in general, the best case for insertion sort occurs exactly when the second half of the while loop condition is false. It occurs if the element is in its exact proper place. So regardless of how large I is, in the best case for insertion sort, the while loop will never run. It will always run 0 times. And what that means is that we will always have only 2 assignment statements in the insert function. In the best case, insert is a constant runtime function, because the size of I doesn't matter. Whether I is 5 or 5 million, insert will take exactly 2 assignment statements to finish, in the best case. So here's the code for insert, along with the code for insertion sort. We'd like to know how many comparisons we're going to make in total for the entire run of insertion sort. When I is 0, the first part of the while loop will get checked. That's one comparison, but then that will fail and nothing else will be checked. And so there's exactly one comparison in the first run of insert with I equals 0. When I is 1, again, in the best case, the first comparison will run, the second comparison will run and will fail. Nothing else will happen, but we'll have 2 comparisons here, because the while loop will never run. If I is 2, the same thing will happen. The while loop conditions will get checked, but the while loop will never run, because in the best case, L at I minus 1 will never be greater than value. We also have 2 comparisons here, and regardless of what I is, the number of comparisons is always going to be 2. So, I ranges from 0 to the length of the list minus 1. Let's see if we can derive a formula for the number of comparisons made by insertion sort in the best case. Now let's call the length of the list n. The total number of comparisons for insertion sort, therefore, will be 1 for the first run of insert and 2 for every other one, and all of this happens n times. There are a total of n terms in this sum. Now what this really means is 2 times n minus 1. All n of these items require 2 comparisons except for the first one, which is 1 fewer. 2n minus 1. This makes insertion sort a linear runtime function in the best case.